Hello and welcome to another session of Java today. This session is about Java classes and objects, Java OOPS concepts. If a vehicle is expected to have a state and behavior, then all cars are instances of vehicle and can be called as objects. Here vehicle is a blueprint or a template and logical entity. Objects are real-time copies of classes. Classes are fundamentals of an object-oriented language such as Java. They contain members that store and manipulate data. Objects have state and behavior which are used to model real-world objects. For example, dogs have state, that is color, breed, and behavior, barking, wagging tail, and cars, they have a state, that is speed, and behavior, brakes and gears. Object stores its state in fields or variables. Behavior as methods and functions. Polymorphism is hiding internal state and requiring all interaction to be performed through an object's methods. Benefits of objects: modularity, information hiding, code reuse, pluggability, and debugging ease. Java classes types. Classes are divided into top level and nested. Nested classes are classes placed inside another class that may access the private members of the enclosing class. Nested classes include member classes, local classes, and anonymous classes. Here class bar is inner class and static class bar is nested class. Classes in a method, that is local class. Here Foobar is local class. Anonymous class. Anonymous class is creation of a new object in a method. Here is a comparison of object versus class. The most interesting. A class is a logical entity. Example, an animal. And object. Object is a physical entity. Let us take an example of lion. Lion is an animal, but all animals are not lions. Animals do have four legs, tail, and lion do have them. Class is declared using class keyword only. Example, class vehicle. Object is created with new keyword. Other ways to create objects are new instance, clone, factory method, and deserialization. Class is like a template created once. Object is an instance of class and can be created, instantiated as many times as required. Classes doesn't allocate memory when it is created. Objects allocate memory when it is created. Declaring classes. Classes declared with class keyword and within curly brackets. Class MyClass. That is within curly brackets. It may have fields, constructors, and method declarations. The class body contains all the code that provides for the life cycle of the objects created from the class. Constructors for initializing new objects, declarations for the fields that provide the state of the class and its objects, and methods to implement the behavior of the class and its objects. You can provide more information about the class, such as the name of its superclass, whether it implements any interface, and so on. At the time of class declaration, for example, class MyClass extends SuperClass and implements SomeInterface. And this may have fields, constructors, and method declarations. Means MyClass is a subclass of SuperClass that implements SomeInterface. We can also add modifiers like public, private at the beginning, which determine what other classes can access MyClass. Non-static members of a class define the types of instance variables and methods which are related to the objects created from that class. To create these objects, a class must be instantiated by using a new operator and calling the class constructor. Accessing class members. Members of both instances and static classes are accessed with the dot operator. Accessing a static class member. Static members are accessed by using the name of the class or any other type. This doesn't require the creation of a class instance. Static members are declared using the static modifier. Modifiers are the keywords used to modify declarations of types and type members. We have these modifiers: abstract, static, final, strict FP. Abstract. This specifies that a class only serves as a base class and cannot be instantiated. Static. Used only for member classes. Specifies that the member class doesn't belong to a specific instance of the containing class. Final. Classes marked as final cannot be extended from and cannot have any subclasses. Strict FP. This specifies all the floating point operations. Access modifiers. The access modifiers are the inheritance modifiers. Set the accessibility of classes, methods, and other members. Members marked as public can be reached from anywhere. If a class or its member doesn't have any modifiers, default access is assured. This table shows access modifiers. This table shows whether a code within a class has access to the class or the method depending on the access class location and modifier for that accessed class or class member. In this private modifier, it has access within the same class, and a default modifier, it has access within the same class and other classes inside the same package. Protected. This has access within the same class and other class inside the same package and extended class inside another package as well. Public. This has access from everywhere. Constructors and initializers. A constructor is a special method called when an object is initialized. Its purpose is to initialize the members of the object. The main differences between the constructors and ordinary methods are that constructors are called only when an instance of the class is created, and they never return anything. Constructors are declared as common methods, but they are named after the class and no return type is specified. ClassA within ClassA. This is the constructor with no arguments, and this ClassA has one argument. Initializers are blocks of code that are executed when a class or an instance of class is created. There are two kinds of initializers: static initializers and instance initializers. Static initializers initialize static fields when the class is created. They are declared using the static keyword. A class is created only once, and static initializers are not called more than once. Instance initializers are automatically called before the call to a constructor every time an instance of class is created. Unlike constructors, instance initializers cannot take any arguments, and they generally cannot throw any checked exceptions. Instance initializers are declared in a block without any keywords. Since Java has a garbage collection mechanism, there are no destructors. However, every object has a finalize method. It is called prior to the garbage collection, which can be overridden to implement finalization. All the statements in the Java must reside within the methods which belong to classes. A method has a return value, a name, or usually some parameters initialized when it is called with some arguments. Similar to C++, methods returning nothing have a return type declared as void. Unlike in C++, methods in Java are not allowed to have a default argument values, and methods are usually overloaded instead. Overloaded method is a method with the same name but with different set of arguments. A method is called using dot notation on an object, or in the case of a static method, also on the name of a class. The throws keyword indicates that a method throws an exception. All the checked exceptions must be listed in the comma separated list. Let us see method modifiers. Method modifiers. We have abstract, static, final, native, strict FP, and synchronized. Abstract methods can be present only in abstract classes. Such methods have no body and must be overridden in a class unless it is abstract itself. Static. It makes the method static and accessible without creation of class instance. However, static methods cannot access non-static members in the same class. Final. This declares that a method cannot be overridden in a subclass. Native. This indicates that this method is implemented through JNI in platform-dependent code. Actual implementation happens outside Java code, and such methods have no body. Strict FP. This declares strict conformance to IEEE 754 in carrying out floating point operations. Synchronized. This declares that a thread executing this method must acquire a monitor. For synchronized methods, the monitor is the class instance or java.lang.class if the method is static. Access modifiers are identical. Fields or class variables can be declared inside the class body to store data. Fields can be initialized when declared. Modifiers. Static. It makes the field a static member. Final. It allows the field to be initialized only once in a constructor or inside initialization block or during its declaration, whichever is earlier. Transient. It indicates that this field will not be stored during serialization. Volatile. If a field is declared volatile, it is ensured that all the threads see a consistent value for the variable. Overriding methods. If a subclass has the same method as declared in the parent class, it is known as method overriding. Abstract classes. An abstract class is a class that is incomplete. Normal classes may have abstract methods, that is, the methods are declared but not yet implemented, only if they are abstract classes. A class A has abstract methods if any of the following is true. A explicitly contains a declaration of an abstract method. Any of A's superclasses has an abstract method, and A neither declares nor inherits a method that implements it. A direct superinterface of A declares or inherits a method, and A neither declares nor inherits a method that implements it. A subclass of an abstract class that is not itself abstract may be instantiated, resulting in the execution of a constructor for the abstract class and the execution of the field initializers for the instance variables of that class. Thanks for watching. Let us see more Java in next sessions.